So let's start with number 1. If you left your answer as, sorry, my pen was freaking out. If you left your answer as an inequality, oh, I have the screen frozen. That was dumb. Okay. If you wrote your answer as an inequality, you should have x less than negative 13 halves or x greater than 1. If you wrote your answer as an interval, you should have negative infinity to negative 13 halves, union 1 to infinity. Are there any questions on number 1? When you subtract 5 from both sides, you're going to have negative 8 minus 5, which is negative 13. Any other questions on number 1? Okay. On number 2, as an inequality, you should have gotten negative 2 is less than or equal to x is less than or equal to 12/5. And as an interval, you should have gotten bracket negative 2, comma 12/5. Questions on either of those? And it tells you what are you looking for on your number line? Where they overlap, okay? So some of you were asking, do you want me to graph? Do we need to graph? In order to figure out where that shading overlaps or is disjointed, I think you should be graphing these on a number line every single time. It takes maybe 10 seconds, right? But it can really show you if you've made a mistake or if your answer is going to be all real numbers instead of 2 inequalities or whatever that case might be. Okay? What's the first step in solving number 3? Good. You have to isolate, right? And then you set it equal to the positive and the negative. And you should have gotten negative 12 and positive 9. Any questions on those? Sure. So if I start by adding 4 to both sides, I'm going to get the absolute value of 2x plus 3 is equal to 21. Then where do I go from here? X plus 3 equals negative 21, and 2x plus 3 equals 21. If you just got, let's see, 12. If you just got 9, if that's the only answer you got, you never took into account the absolute value. You cannot just ignore that the absolute value is there and try and solve it like a normal equation, because then you've just completely disregarded the purpose of the question and you made it an Algebra 1 question instead of an Algebra 2. Okay? You can't forget that that absolute value is there. So you have to split it. So you get 2x equals negative 24, and that's where my x equals 12, negative 12 comes from. Over here I get 2x equals 18 and x equals 9. Does that help? Okay, cool. Okay. Today what we're going to talk about is absolute value inequalities. So on Friday we talked about absolute value equations and linear inequalities. Today we're talking about absolute value inequalities. Okay? This is a challenging topic that trips people up. So it's really, really important that you're focused, paying attention, writing down hints that I'm telling you, things like that. Okay? All right. So let's start just conceptually looking at this graph. Okay? Would you agree that this is the graph of y equals the absolute value of x? Yes. Okay. Now I want us to think about, what if I wanted to know for which part of this graph the y values are greater than 5? I wanted to know which part of this graph the y values are greater than 5. What line might I plot on my absolute value graph? A horizontal line at what y value? 5. So let's just kind of eyeball that. And I'm going to plot this horizontal line. I'm going to call this y equals 5. So for which parts or part of my absolute value graph are the y values greater than 5? Okay, so it's this piece above the line, right? Would you agree with that? It's those two pieces. So that means for my x values, it's this part of my x values and this part of my x values. These x values, when you plug them in, you're going to get y values bigger than 5. Would you agree with that? Okay. Now, picture this x-axis as my number line. Okay? When I plot this solution on my number line, is that a conjunction, like an and, or a disjunction, like an or? This is a disjunction. Oops. It's a disjunction, which implies or. Okay, and that's because it's only everything that's less than this x value and bigger this x value. Now for this nice simple graph, we know that that's less than -5 and greater than +5, right? But it's going to get a little more complicated than that. But the idea is when you are dealing with a greater than, when you have your absolute value dealing with a greater than, it's always going to be a disjunction. It's going to be an or. And this is the reason, because it's the two ends of your absolute value graph. Okay? All right. Let's talk about if we want to talk about less than 5. The absolute value of x is less than 5. I would still graph the line y equals 5, right? But this time, which piece of the graph do I want? What's below it? So this piece, right? Would you agree with that? Which means that the x values, if you go down to your x-axis on your number line, it's these x values, right? Do you agree with that? Okay. So, sorry. So, does this piece of my x-axis, does that shaded region of my number line represent an and or an or, a disjunction or a conjunction? A conjunction, which represents what? And. So anytime your absolute value is less than a number, you're going to have and. Okay? Okay, so here's a hint. Greater, like greater than, but we can think of it as great or. Greater than means or. And less and. Instead of less than, less and. Okay, so great or and less and can help us remember if we're going to have a disjunction or a conjunction. And versus or. Okay? Now, this only works, this great or and less and only works when the absolute value is isolated on the left side of the equation. Sorry, not equation, inequality. Great or and less and only work when the absolute value is isolated on the left side of the inequality. Okay. Another hint that I've seen people use is the word goal. Which would represent greater than, means or, and means less than.
You can also use the fact that like the less than and the greater than signs look like a C and a D for conjunction and disjunction.
Ah, I like that. Okay, so what he's saying is that if I have my greater than sign, I can turn that into a D for disjunction. And if I have my less than sign, it's like a C for conjunction. Cool, I like that one. So, lots of different ways to remember. It's up to you to figure out what works for you, okay? It's up to you to figure out what works for you. So, let's talk about two special cases. Absolute value of x plus 2 is greater than or equal to negative 2. I'm going to kind of sketch myself a little graph here. Would you agree that this is the parent function transformed left to? Okay. Which doesn't really matter too much in this case, but we'll still be accurate where we can. And the line y equals negative 2, would you agree is down here somewhere? Okay. So what part of my absolute value graph is greater than, has y values that are greater than negative 2? All of it, the whole thing. Why does that make sense? Okay, so we know we only have positive values. Our range is 0 to infinity. And when I take absolute value, it's always going to be positive. So a positive number, when is a positive number going to be greater than or equal to a negative number? Always. So my answer is either all real numbers or negative infinity to infinity. You want to make sure you're paying attention to this so that you can stop yourself from having to do more work for less points. Okay? You want to notice that when you get an absolute value greater than a negative, you stop right there. It's all real numbers. Okay? What about the flip side? What if we get the absolute value less than a negative? So picture your absolute value graph. I picture my line y equals negative 2. Yeah, is this graph ever going to be below my line y equals negative 2? No, so this is never true because a positive is never going to be less than a negative, right? Can't happen. So when it's negative true, or sorry, never true, whoa, sorry. When it's never true, your answer is no solution. Okay? All right. If you are the type of person that likes to have steps to solve things like I am, here are the steps for how you would solve your absolute value inequalities. Okay? If that won't help you, don't worry about writing it. I just wanted to give you the option. So we start every single time, just like in equations, with isolating the absolute value. Okay? Guys, if you don't do this, or if you do this incorrectly, the rest of the problem is wrong. There's really nothing else you can do, okay? So that is such an important first step. You've got to beat it into your brain almost to make sure you're doing it every single time, okay? Then you'll understand what the think bubble means in just a second. But basically, you've got to decide, is it and or is it or? Great or, less and. We've got to decide. We're going to write our inequalities so that we can solve them. And then we're going to check our answer on a number line and check the values that we come up with. Okay? All right, let's give it a try. What do we do first? Isolate the absolute value. How can we do that here? Add 4. Awesome. So I'm going to get 3 plus 2x is greater than or equal to 13. All right. So the way I do it is not necessarily the way you have to do it, but here's what I do from here. Okay? I kind of have to stop and think. So I make myself a little think bubble. And I go out to the side, and I've got to decide, is this and or is this or? So you can picture a couple different things. You can write out your goal. You can write out great or, less and. I could picture the graph. So let me think about if I picture this graph. Okay, it's not really going to be on an axis, so I don't really need that. Oopsies. So I picture my graph, and I want everything greater than 13. So does that mean I want the ends or the middle? The ends. That's the piece that's bigger than 13, right? Good. So that means it's or. Okay? And on a number line, that means it would go this way and this way, right? What do you think these values are right here? Okay? Well, yes, my final answer is going to have an or in it. But to set up my inequality, these are negative 13 and positive 13. Okay? Because the inside has to be bigger than positive 13 or less than negative 13. So that when I take the absolute value of it, the distance from 0 is bigger than 13. Okay? So this is an or, and it's going to turn into 2 inequalities. I take the inside, 3 plus 2x, and to represent this left side of my number line, it's going to be less than or equal to negative 13. The inside can also be greater than or equal to positive 13. Okay? The reason that this sign flips is to create is to create this left part. The inside, the distance from 0 of this whole thing is bigger than 13, which means it's either got to be bigger than positive 13 or smaller than negative 13. Because say I've got a value here, negative 15, would you agree that that's got a distance from 0 that's more than 13? So that's why I have to go less than the negative. That's what creates the or. Greater than the positive, less than the negative. That's what makes it go in opposite directions.
So signs will always correspond with the less than and the greater than.
What do you mean by the signs?
The negative sign is always going to have a less than or equal to, and the positive is always going to have a
For or, yes. Okay. Now, if this started as just a greater than, do you understand that none of these would have equal to's? But they have equal to's because it started as an equal to. Okay? All right, let's solve each of these. The cool thing is that now this is just like the stuff we did on Friday. The hardest part, and I'm not belittling it, it is hard, okay? But the hardest part is writing these inequalities. After that, it's a piece of cake, because we can just solve it like we did on Friday, okay? So let's go ahead and solve. I'm going to subtract 3, so I'm going to get 2x is less than or equal to negative 16. X is less than or equal to negative 8. 2x is greater than or equal to 10. X is greater than or equal to 5. Okay, we started as an OR. We need to check that we're finishing as an OR. Okay, so let's go ahead and plot this. Which way do I shade from negative 8? Which way do I shade from positive 5? Did I finish as an OR? Yes. Awesome. So that means your final answer can be written in 2 ways depending on how you're asked. If you're asked for inequality notation, that is your final answer. If you were asked for interval notation, what's your final answer going to be? Questions? You okay? All right, cool. Let's try again. Four times the absolute value of x plus 5 is less than or equal to 7. What do I have to do before I go on and think about this? Awesome. All right, how do I do that first? Good. I have to do this 5 first. This is 4 times the absolute value of x is less than or equal to 2. Then what? Divide by 4. So the absolute value of x is less than or equal to 1/2. Okay? Now this one's a really simple one, right? Because there's no stuff happening on the inside. But I still want us to practice our process. So I'm going to draw my think bubble. I'm going to draw my graph and my line that's going to represent 1/2. Which piece do I want? The ends or the middle? Which piece is below 1/2? This part, right? Because it wants the absolute values that are less than 1/2. So that means if this is line represents y equals 1/2, this is the piece below it. Okay? So each time you just want to kind of think about plotting that line and figure out which piece. Okay? So is this and or? And, which makes sense, right? Because we said less and. And this is a less than, which means and. Yeah?
So do you base your thought bubble off the last sign versus the original?
Yes. You always base that thought bubble after you've isolated the absolute value. Once it's isolated, then you can do all this manipulating. Okay, good question. Okay, so this is an and, which means that the inside, and in this case it's simple, it's just x, but if this was more complicated, the inside has to be between negative 1/2 and positive 1/2. The inside has to fall between those things. Okay? So this is an and, so I want to come over here and write this as an and. So what goes on the very left? So negative 1/2 is less than or equal to what's inside my absolute value in this case? X, which is less than or equal to 1/2. Now this is really nice. I don't really have anything else to do in this case. But I could have it where I have to solve for x now. Okay? So is negative 1/2 less than 1/2? So in this order, things make sense. What would this be? Or so if I plot this on a number line, it's going to look just like that other one we drew, but that doesn't always happen, right? It's just because the inside happened to be just x. And as an interval, negative 1/2 to 1/2. they only gave us the inside equal to x, but a lot of our problems are going to have stuff going on the inside. Okay? We okay? Great, or, and less and. All right, let's look at number 3.
At first, I just thought you said the 2 words wrong.
Tell me what you would like to do first on number 3. Ooh, we all knew that one. Okay, now my absolute value is isolated, so where do I go from here?
Think though.
Yeah, I got to kind of think.
Do we always have to write this?
No. I'm going to recommend that you do it because I think it's helpful. But if you get to the point where it's second nature to you, that's fine. But when you start missing questions without writing this down, then I'm going to harp on you to write it down. Okay? All right, so less and if I graph this, which piece do I want? The bottom. So this is and, which means that what's going to be, my inside is going to have to fall between what 2 values? -3 and 3. Open circles or closed circles at 3 and -3? Closed. Why closed?
Equal.
Yeah, it's equal to. Are they always going to be closed? No. I, for some reason, made all examples with equal to's, and I apologize for that. So I'm just going to keep reminding you that it can be an open circle. Okay?
But both of them would be open.
Right. They're either both going to be open or they're both going to be closed. Good. Okay. So then I come down here, and I rewrite this as an and. So I take my inside, my 2x plus 7, and it's got to be between 3 and -3. So it's got to be less than 3, and the inside's got to be greater than -3. And sorry, these should have equal to's.
Oh, do we have to write them in one inequality?
If you really, really hate it, you can split it. I would recommend you keeping it together, okay? Because you want your answer to end up together. But if you separate it and just bring it back together, as long as you do so accurately, that's fine. Okay?
How would you solve this?
How would we solve this? What are we going to do first? Good. What you do to one part, you do to every part. So what am I going to get rid of first? All right, so I subtract 7 from every part. So this is -10 is less than or equal to 2x is less than or equal to -4. Next step? Divide by 2 on all 3 parts. -5 less than or equal to x is less than or equal to -2. Okay? So let's plot this. Here's -5. Here's -2. So let's think about what this is saying. -5 is less than or equal to x, and x is less than or equal to -2. So is that possible? Can my x values be bigger than -5 and less than -2? Yeah. They just fall right in here, right? But we have to be careful because haven't we seen those and inequalities that they don't work? So we've got to think about making sure it works. We can't just jump straight from there to our answer. Okay? You got to make sure you didn't do anything incorrectly. Okay. So my final answer as an interval would be -5 to -2. And this is your final answer as an inequality. If you do split your inequalities and it's an and for your final answer, it's got to come back together. Okay? Now, I've been setting a very bad example. What was the last step that I told you you must do? Check. Okay? So I've been not doing that, which is bad. Okay, so we checked that the answer we got is possible. Okay? But now we need to check that we actually set up our equations the right way and shaded the right way. So what would be a number between -5 and -2 that would work for us to check? -3, -4, -2.5. Okay? Let's try -3. 2 times -3, -6 plus 7, 1. Absolute value of 1. 1. 1 over 3 is 1/3 less than or equal to 1. Yes. Okay. That's how you check the ands. You pick a number in the middle. For an or, you would have to check a number in each piece. Okay? So, like, on number 1, I would plug in, say, 6 and -9. And I would make sure that those would both work. Or 10 and -10, if those numbers seem easier to you. You can pick the easier number. You just got to find something in the shaded region. Okay? You would pick a number and plug it into the very original equation. Yep, you'd pick a number from this shaded piece and this shaded piece. Okay? So do not follow my bad example. You check every single time. Okay? You're trusting me. Hey, that's dangerous. You've seen the mistakes I made. Okay. Number 4, -1/2 times the absolute value of x minus 2 is greater than or equal to 3. Okay, tell me what we would do first. Times 2, what kind of 2? Negative. Okay, so when I do that, what happens to my sign? Flips. So I'm going to get the absolute value of x minus 2 is less than or equal to what? -6. Think about this. Here's my absolute value. Where's the line y equals -6?
Below it. So it's
Below it.
all the numbers.
Yeah, it's always. Remember that special case we talked about at the beginning?
Yeah.
Okay. Oh, wait. It's not always.
Never.
Yeah, it's less than, right? Sorry. I was just so convinced that you guys had it. Okay. Sorry. All right. Think bubble. We drew our think bubble. We drew our absolute value. We drew the line y equals -2. Now it asks us for less than or equal to -6. When is this graph going to be below this line? Never. Right? We can stop and see it right here. An absolute value is what kind of number? Positive. Is a positive ever less than or equal to a negative? No. So when it's never, what's my answer? No solution. Now, say you actually kept going and set up your 2 number lines, right? And you set up your inequalities. You would end up getting, this is a less than, right? So say you didn't recognize it here. You set up your and inequality and you tried to plot it on a number line. Would it work when you tried to plot it? No. You'd get a bigger number over here and a smaller number over here, and that wouldn't work. So you've got 2 places to catch yourselves. I'd rather you catch it right here because that's less work for you. Okay? I like less work for maximum profit. Okay? If you do more work and you have a risk of messing up and getting the wrong answer. Okay, look at number 5. -2 times the absolute value of 3x minus 8 minus 7 is less than or equal to -2. What do I do first? Good. Add the 7. Then what? Okay, so when I divide by -2, my sign flips. So I get 3x minus 8. The absolute value of 3x minus 8 is greater than or equal to what? Careful. -5/2. Okay. Now, I have my absolute value graph, and I want to know when is that bigger than a negative y value? Always. All of this is bigger than, because I have a positive greater than or equal to a negative, and that always happens. So what's my answer? All real numbers. How would I write that if I was asked for interval notation? Negative infinity to infinity. Okay, your homework assignment has been cut down a little bit, so please get this revised assignment. 20 to 27. 36 and 45.